purpose of what we're going to do today is that there are various viruses that affect bees across the world. There are about 15 known viruses, possibly more at this time, that do affect bees. And this project, one of the aspects of this project is to first identify what's the varroamite load, because these are the vectors. Varroamite functions as a vector for these viruses. And secondly, what viruses are present. And then thirdly, what species of bee we are taking the samples from. Doing a varroamite test, so we're putting some isopropyl rabbit alcohol. We're going to collect about 200 bees in there, 100-200 bees, so she's not there. Turn it. Turn it, turn it, turn it. So we've taken our mite test and we've taken our RNA sample to test for viruses. The RNA sample is labeled DS4. 4 represents the number of the hive and DS represents the initials of the beekeeper. Alright, so we've got those samples there. We're also going to take the samples which we did for the varroamite test. We're going to do a wing scan analysis on those. So we'll just take a few of those bees, drop them in here. Preserve them in some rubbing alcohol. And I'm going to label that sample DS4. Bees do not have an adaptive immune system due to the lifespan. Worker bees and drones only have a lifespan of around 35 to 45 days, and the queen can last up to 2 to 3 years, but she is also the sole producer of any eggs. So if the queen is infected with viruses, she potentially can pass those on vertically to her offspring. So it's very important the work that we're doing now is to identify what viruses are in the colonies, and hopefully whilst we're doing this analysis we will come across colonies which are free of any viruses, and these will be ideal colonies for us to breed from to reproduce more queens. About 200 to 300 bees, and we'll see what's the level of mite infestation. And then secondly, we'll take a second set of samples to send off to a laboratory to do the viral load testing, and we'll submerge those bee samples in a solution called RNA later, which will preserve the RNA of these bees for up to 3 weeks. Without very cold refrigeration. Historically, when we've tried to do this experiment, we've had to rely on using dry ice and freezing the samples of bees just before we were ready to send them off to the lab, and hoping that the dry ice will preserve them preserve the RNA in the bees long enough for them to be put in a -80 refrigeration, and then the analysis conducted upon them. So using this RNA solution is very advantageous for us because it makes taking sample work in the field much easier. However, this solution is very, very expensive. Okay, this one has 3 mites. See them underneath. 4, no, 1, 2, 3, 4, 5. Alright, so we got 5 mites there. Yeah, we're gonna do wing scan with those. Yeah, I know. Alright, so we got 5 mites.